In this module, I'm going to be covering the concept of equilibrium. We saw a little bit of equilibrium pop up when we discussed equilibrium vapor pressure, but now we are going to discuss equilibrium as it relates to a reaction. So if we were given the reaction A proceeds to B, the first thing we need to denote is that B can also proceed to A. In any equilibrium reaction, the reactants can proceed to the products, and the products can also proceed to the reactants. Now, if we were to start with 10 molar of A and 0 molar of B, one big misconception we need to avoid making is saying that equilibrium will be established when there is 5 molar of A and 5 molar of B. This is not true. It could be true for equilibrium, but equilibrium is not when the reactants equal the products in terms of their concentration. What we need to discuss equilibrium as is these are the rates for the forward direction and the reverse direction. So again, equilibrium is not when the concentrations on each side are the same. We will see equilibrium. So I will write this down. Equilibrium is when the rate of the forward direction is equal to the rate of the reverse direction for this reaction. So at equilibrium, we could have much more B than we do A. However, as soon as the rate that we are producing B is equal to the rate that we are producing A are equal, that will be equilibrium. One analogy I like to make is with a large field. So picture we are in an open field outside. We'll call this side A, we'll call this side B. So this is our field. Picture we put 100 people on this field and they can go to either side. So maybe we have a couple people over here, right? This will not be to scale. And then say we have maybe a few people over here. Say this is our 100 people. Now, what we can say is that we can run this reaction. Maybe a lot of A will start proceeding to B, meaning a lot of people will start running over to the B side of the field. So what we can say is that maybe over a given amount of time, we're left with only a couple people on side A, and we're left with a bunch of people on side B. However, if we were to establish equilibrium in this field, essentially what we're saying is basically for every one person we send over, so if we send one person over, we send one person back. So basically the rate that we are producing B is equal to the rate that we are producing A. Essentially the rate of people running over to the B side is equal to the rate of people going from the B side to the A side. Once those two things are equal, equilibrium is established. As we can see, if we were to call this equilibrium, we would have much more people on the B side, and it really wouldn't matter. We would still be at equilibrium. So reactions work the same way. You can have a reaction where there is a lopsided amount of products or a lopsided amount of reactants, and equilibrium can still be established just based on what that reaction wants to do. So please don't make the misconception that equilibrium is when there is an equal amount of people on each side of the field or the concentrations equal out. It is all about the rate that the forward reaction is being run and the reverse reaction is being run. So in the following videos, I'm going to be discussing a little bit more about equilibrium and how we can solve some problems associated with it.